Alright, so today I'm going to show you how to balance chemical equations. To start off, I'm going to introduce some of the parts of a chemical equation. So to start off, here is an example of a chemical equation. This is photosynthesis. Photosynthesis is when plants bring in H2O, which is water, CO2, carbon dioxide, and yields or makes sugar, which is C6H12O6, and then oxygen, O2. Each one of these symbols means something. So the H means hydrogen, the O oxygen, C carbon, O oxygen, C carbon, H hydrogen, O oxygen, O oxygen. You'll see these little numbers below each letter. This means in this molecule of water that there's 2 hydrogens and then 1 oxygen. In carbon dioxide there's 1 carbon, 2 oxygens. In sugar there's 6 carbons, 12 hydrogens, 6 oxygens, and then oxygen molecules come in pairs, 2 oxygens. On the left hand side, you will almost have on the left hand side the reactants. So my reactants are H2O and CO2. And then you'll see this yield. In math you usually have an equal symbol, but in chemistry we use a yield symbol, which means that the reaction is going from the reactants to the products. Then my products are sugar, C6H12O6, and then oxygen, O2. The subscripts cannot be changed. They must stay the same. You can't change these letters or numbers. But we have these coefficients in the front that we can change. And so I'm going to show you how to change this and balance it with another chemical equation. But first I'm going to give you some clues and rules. First off, you have conservation of mass, meaning whatever you have on the left hand side you have to have on the right hand side. So your products and reactants have to have the same number of atoms on both sides. Another tip would be to balance oxygen and hydrogen last. So if you have an equation with just oxygen, make sure you do that one last. If you have an equation with hydrogen, make sure that one's last. If you have both oxygen and hydrogen, my tip is to do hydrogen second to last and then oxygen last. So let's go ahead and try this with another really common chemical equation, and that's respiration. Respiration is when we breathe in oxygen and then we also eat sugar, and then we breathe out carbon dioxide and water, H2O. So I find it easiest to visualize and look at it by drawing a picture first until we're comfortable with the concept. So I'm going to draw all the different atoms in one molecule, because we know there's at least one molecule in this chemical equation. So we're going to draw 6 carbons, and I'm going to have the carbons be black. So there's 1, 2, 3, 4, 5, 6. I'm going to have my hydrogens be blue. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then my oxygens, I'm going to do red. And there's also 6. 1, 2, 3, 4, 5, 6. And I know this from the subscripts in the molecule. Then I have oxygen, they come in pairs. So one molecule comes in a pair. And then my carbon dioxide, there is 1 carbon, 2 oxygens, and then in my water there is 1 oxygen and 2 hydrogens. So starting with that rule, to start with, end with oxygen and then have my hydrogen be second to last, that means I should start with carbon. So if I look at this, I have 1, 2, 3, 4, 5, 6 carbons on this side. I need to have 6 carbons on this side. So I'm going to add CO2 molecules. So I have 1, 2, 3, 4, 5, 6. 6 carbons. So now my carbons balance. However, CO2 carbon comes with 2 oxygens. We have to have the carbon with the oxygen. So there's 2 oxygens for each carbon. Okay, so now my carbon's balanced. Now I'm going to do my hydrogen, second to last. So I have 12 here, so I need 12 hydrogens over here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But just like the carbons, the hydrogens, or the carbon dioxide, the carbon came with oxygen. Just like that, the H2O or water comes with two hydrogens and 1 oxygen. So for each one of these pairs, I need 1 oxygen. Alright, so now my hydrogens balance, I have 12 on both sides. My carbons balance, I have 12 on both sides. And now I need to balance my oxygen. So I just do that by counting up all my oxygen. So I have 6 times 2, so that's 12, plus another 6, that's 18 oxygens. So 18 oxygen on this side. That means I need to have 18 on this side. So I start and see what I already have. I have 1, 2, 3, 4, 5, 6, 8. So 6 plus 2 is 8. I could get some more oxygen by adding a whole nother sugar molecule, but if I do that, I'm going to unbalance the carbon and I'm going to unbalance the hydrogen. Right here I can just add oxygen and they come in pairs. And so I need 10 more, because I already have 8. So there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now if I count these, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 oxygens on both sides. So now all my atoms balance. Now I can put in my coefficients. The coefficients just means how many molecules of that certain molecule I have. So if I look at this, I have 1 sugar. So I'm just going to put a 1 right here. I have 1, 2, 3, 4, 5, 6 oxygens, 6 oxygen molecules. And then I have 1, 2, 3, 4, 5, 6 carbon dioxides. And then I have 1, 2, 3, 4, 5, 6 H2Os. I have different colored markers here so I can make these different colors. If you don't have that luxury, you can always just make a circle and then put the symbol in. So that would be carbon, that could be my oxygen, and that could be my hydrogen. And that's something you could do on the back of, another piece of paper or the back of your paper to find out. And use different symbols on your paper. So, if you are comfortable enough to not use pictures, that's okay. I'm going to go ahead and show you how I do it without using pictures. But there's other ways and you don't have to necessarily do it my way. So first, starting with the non-oxygen, so I have oxygen and hydrogen. So I'm going to do oxygen very last and hydrogen second to last. I'm going to start with SN, which is tin. So if I look on this side, I have 1 tin and 1 tin. So I'm going to say I have 1 here and 1 here. And they're balanced, so that's good. So I can move on to my hydrogen. If I look at my hydrogen, I have 2 here and 2 here. So we're good there. I have 2 and 2, so we're balanced. If I look here, I have 2 oxygens. And I only have 1 here. So that's a problem, they don't balance. So I need 2 here. But if I double my oxygens, I also have to double my hydrogens. So that means I have 4 hydrogens here. Now my hydrogens are unbalanced, so I have to go back and change this to 4 so it balances. So if we look, now I have 1 tin and 1 tin on both sides of the yield. I have 2 oxygens on both sides of the yield. And then I have 4 hydrogens on both sides of the yield, so we balance. Then I need to just put in my coefficients. So I just think of it as what number right here multiplied by 1 or multiplied by 2 would get these numbers. So 1 times 1 equals 1, or 1 times 2 equals 2. And we can use both of those to double check. Here it's what number times 2 equals 4. So 2 times 2 equals 4. 1 times 1, so there's these 1's right here. We just don't put them because we're lazy, basically. So 1 times 1 equals 1. And then 2 times 2 equals 4, or 2 times 1 equals 2. And so that's how I do it without drawing pictures. And like I said, there's other ways that you can do it. Whatever works best for you, go ahead and do. Hopefully this was helpful, and if you have any questions, go ahead and talk to me.